So we will also look into some more complex cases, and for example, for a circuit with a battery and some resistors in parallel and some in series, we will simplify the circuit in steps by finding equivalent resistances, and then reverse the steps to find the currents and potential differences of the individual resistances. Okay, and we did similar calculations in the capacitor section for chapter 25. So we're going to do that for resistors this time. And if a circuit cannot be simplified by using equivalent resistances, we will identify the several loops in circuit and choose names and directions for the currents in the branches, and we'll set up loop equations for various loops and then solve these simultaneous equations for the unknown currents or anything unknown really. So this is going to be the KVL part here and KCL as well, because we will be using junction rules, but mostly KVL. And this is the way that we will be doing equivalent resistance way. Some problems can be solved both ways, and sometimes we will practice both ways on the same problem. And I have some example problems in the workout set. Okay, so I will make sure to check those. They're good practice. Again, we have some examples. We will do these in class. I just want to get to the last part, how to connect a meter and the voltmeter. So in this case, we already did practice this in the lab, and just want to briefly go over kind of how do we do this properly. So a meter is, and also it's important to kind of know the connection and like kind of the concepts. For example, the current is through the element, right? The circuit element, and voltage is across. So those really, the words are important to really understand and have to measure as well. So a meter is connected in series because again, current is through the element. So you need to connect it next to it so that same thing goes through the ammeter, and you can find out the current. Okay, and the voltmeter is going to be connected parallel because it is measured across the element, in this case the resistance or resistor, and so that's why we connected parallel. Okay, so that's going to be important, how they're connected, and we already did that in the lab, and we will be doing that again in next week's lab as well. So that's going to be important part. And to not get much effect from the connections of ammeters and voltmeters, what we need is a very small resistance compared to other resistances for ammeter, and you need a very large resistance compared to other resistances in the circuit for the voltmeter. If you recall what we did in the lab, just this recent lab you did, we did needed to connect ammeter and voltmeter in different slots, right? Because again, what's really changing is these resistances. Okay, on one of them you need small resistance and the other one needs big resistance. So if you look at the voltmeter, you need big R because resistance is on this branch here where the voltmeter is connected. If you have really big R here, that's going to create more resistance. So when the current splits up from here and there, there's more resistance on this where the voltmeter is, and there won't be much current drawn to it. Okay, so that means the same current is going to be, almost the same current is going to go through this R1, and that way we won't really affect the results when we measure V1 on R1, for example. Okay, so you want the same current flow through it. So this junction is kind of, you're not letting much current going through the voltmeter. How do you do that? If you have a really large resistance. It is opposite on an ammeter. So we want the resistance very small on this ammeter compared to the other R's, because you don't want to create a potential difference here. Okay, so you don't want to change the potential difference you don't want to share the potential difference with the other R's. And if you have a small r, V is equal to IR, since you don't want to change the current, if you have a very small R, you're going to get a very small voltage so that you can keep the current the same, and you barely change the voltage, the shared voltage among the other resistors, because you're not really getting much of it if you have really small resistance. Okay, so that's the reason that when you connect the ammeter and voltmeter, it's different connection. And also you need to, when you use your DMMs, you cannot use the same wiring. You have to switch so that you can change that internal resistance and you can get more accurate readings. And then we will go through some questions, and next lecture we'll start the RC circuits.